So let's talk about isotopes and counting subatomic particles. Now there are some very important terms that you need to know. So you need to know that atoms, specifically, have a neutral charge because they have the same number of protons as the number of electrons. Now ions do not have a neutral charge. Ions are atoms that have gained or lost electrons and have a charge. So positive ions are going to have more protons than electrons by the amount of the charge. And negative ions are going to have more electrons than the number of protons by the amount of the charge. Now isotopes can be ions or atoms, but what makes them special is the fact that they have different numbers of neutrons. Now in chemistry, we are all about scientific notation, so we have a specific way of writing isotopes. Now, generally, when you're given the name of an isotope, you'll be given the element name, dash, and then the mass number. So, from the name, you can find the symbol on the periodic table. You can also get the atomic number from the periodic table. The mass number goes to the upper left, and then if a charge is given, it would go on the upper right. So, for example, if I give you potassium 39, the 39 goes here. From the periodic table, potassium has a symbol of K. And the atomic number from the periodic table is 19. And since this is an atom and they didn't tell me anything about a charge, I'll leave this blank. So if I asked you to tell me the number of subatomic particles in this particular isotope, because of the atomic number being 19, it has 19 protons. Because it's an atom, I can use the atomic number for the number of electrons, so it'll be the same, because that's the definition of an atom. And then remember our acronym of MAN from the notes, where the mass number minus the atomic number would give you the number of neutrons. So if we take 39 minus 19, that gives us 20. So if we look at a few more examples with ions, because they're sneaky, we'll look at this one first. So chlorine has a symbol of Cl. Okay? And when I look at my handy-dandy periodic table, I can see that the atomic number of chlorine is 17. So 17 will go here. My mass number will go to the upper left. And they told me a charge this time, so it has a positive 1 charge. That goes to the upper right. So now when I'm counting the parts, the atomic number will tell me the number of protons is 17. The number of neutrons will be 35 minus 17, which is 18. Isn't it lovely how that is set up for you? And then now notice the charge is plus 1. That means there's 1 more protons than electrons. So 17 is 1 more than 16. So if we look at another negative ion, so now we're dealing with nitrogen 16. Now nitrogen has the symbol of N. And if I look at my periodic table and find nitrogen, I see that it has an atomic number of 7. So 7 will go here, 16 will go on top. And nitrogen, this nitrogen has a negative 3 charge. So for my number of protons, I use the atomic number still 7. If it's nitrogen, it has 7 protons. Now, notice it says I have 3 more negatives. So that means that I have to have 7 plus 3 electrons, which is 10 electrons. Because then there's 3 more electrons than protons. That's the negative part. Remember, electrons are negative. And then for our number of neutrons, we can do our 16 minus 7. And we can see that we will have 9 neutrons. Now, magnesium is forming a positive 2 ion. This is magnesium 26, is how you read that. Now, magnesium, notice, this one's magnesium. This is manganese. Some of you have been getting these confused because you've been reading too quickly. Magnesium is Mg. It has an atomic number of 12, as we just saw. And the mass number given is 26. and then the charge will go to the upper right. So for the number of protons, magnesium has 12 because of the atomic number. And for the number of electrons, notice it has 2 more positives, that's the protons, than electrons. So 12 is 2 more than 10. And then for the number of neutrons, we can do 26 minus 12 for 14 neutrons. And our last example is aluminum 26. So the symbol for aluminum is Al. We look on the handy dandy periodic table and see that the atomic number is 13. The mass number comes down. Has a positive 3 charge. So for the number of protons, I can use the atomic number of 13. Now this ion has 3 more positives than negatives, so 13 is 3 more than 10. And then 26 minus 13 is 13. There you go.